Our last speaker of the day, Casey Young, who is going to talk about sex-specific disruptions in lipid metabolism and GBA-1 Parkinson's disease.
All right, so this project was done alongside my mentors, Dr. Rachel Saunders-Pullman and Matt Sinai, and Dr. Stephanie Bennett at the University of Ottawa, in collaboration with Yusuf Hannan and Lena Obeid at SUNY Stony-Brook. I know we've discussed these pathways in depth earlier in this conference, but I'm just going to focus again briefly on the sphingolipid pathways relevant for this discussion, particularly on the hexosylceramides. And so hexosylceramides are a group comprising both glucosyl and galactosylceramides. And hexosylceramide levels are regulated in three ways. Firstly, by the removal of the glucose head group by GCases encoded by GBA-1 and 2. And secondly, in the opposite direction, transfer of the glucose head group to ceramides by UDP glucose ceramide glucosyl transferase. And thirdly, as Dr. Feldman just described, hexosylceramides are converted to hexosylsphingosines by acid ceramidase, particularly ASAH1. For this analysis, we obtained blood samples from 4 different clinical cohorts through an NIH grant: Mount Sinai Beth Israel, the Harvard Biomarker Study, the Parkinson's Disease Biomarker Program, or PDBP, and the Michael J. Fox Foundation BioFind. An evaluation of the sphingolipid pathway was performed at 2 labs, initially at SUNY Stony Brook, and then after further deliberation, we decided to verify the quantitations. So the samples were rerun at the University of Ottawa. We analyzed the plasma of 67 control women, 50 control men, 47 GBA-PD women, and 62 GBA-PD men. And we found that GBA-PD women and men showed different lipidomic signatures in plasma. For this discussion, I'm going to be focusing on only one of 13 different metabolic pathways that we've tracked in controls and GBA-PD women and men. Specifically, I'll be discussing a sphingolipid species with a sphingosine backbone, D18-1, that is an 18-carbon chain with a 1 double bond and acyl chain. And so, interestingly, as we see in panel A, the hexosylceramide levels are significantly elevated in GBA-PD women, but not men. And furthermore, as we see in panel B, hexosylsphingosine levels are elevated in GBA-PD men, but not women. So in order to interrogate the steps that may account for these differences in abundances, Dr. Bennett and Dr. Alakou have used novel bioinformatic tools that assess the extent of activation of sphingolipid pathways in steady-state lipidomic data. These tools were developed at the Bennett and Schlossmacher laboratories in collaboration with Dr. Miroslava Krpalevic-Kolf at the National Research Council. And so the strength of the pathway activation relative to steady-state controls is shown in gray and teal in the center panel C, and actual abundances are shown in gray and red in the left and right panels, A for the ceramides and B for the hexosylceramides. We found that the activation pathway conversion of hexosylceramide to ceramide is equally impaired in both GBA-PD women and men, yet a significant elevation of hexosylceramide levels are only seen in women. And so, brached in red here, we've inserted a panel showing pathway activation in the other direction from conversion of ceramide to hexosylceramide. And we found that the activation pathway is significantly lower in GBA-PD men compared to both controls and GBA-PD women. And so thus the interpretation is that GBA-PD men appear to compensate for impaired GCase activity by downregulating this glucosyl transferase pathway, whereas GBA-PD women continue to synthesize hexosylceramides despite this impaired GBA-mediated hydrolysis. And so in panel E here, we further show that GBA-PD men shunt hexosylceramide to hexosylsphingosine. And we see here that there's a significant increase in this activation pathway for GBA-PD men compared to control men. And furthermore, while not statistically significant, the difference in the pathway activation between GBA-PD men versus GBA-PD women is at the level of P equals 0.06, which suggests another possible sex-specific compensation that impacts on this aberrant sphingolipid metabolism. And so a larger sample is going to be analyzed to see whether this continues to bear out. The data I've presented today is for hexylsulceramides that were run at SUNY Stony Brook. In addition to verifying that data at the University of Ottawa, Dr. Bennett and Dr. Alaku have also run DMS for glucosal alone, and those findings show the same conclusions as for hexylsulceramide, though I don't have the figures to show that today. And so some preliminary conclusions. Substrate reduction and small molecular approaches targeting ceramides and or glucosal transferases may be better suited to treatment of GBA-PD women and could potentially be ineffective in GBA-PD men. And this is because men already have reduced activation of that glucosal ceramide synthetic pathway through the compensatory downregulation. And conversely, therapies that are focused on reducing acid ceramidase activity may be better suited to treatment of GBA-PD men, and should these findings hold, could even be contraindicated in women, considering that they could further increase glucosal ceramide levels. One additional or alternate explanation is the role of genetic modifiers and or other epigenetic processes. And so we're looking at this further in collaboration with Dr. Ozelius and Ali Domingo at MGH on the genomic side, and Dr. Raj and Oriel Narcis on the transcriptomic side. Our data needs to be further validated in larger cohorts, and we're still evaluating it, particularly in sensitivity analyses segregated by mutation type. But until this time, one may want to consider a randomization schema allocating women at the same ratios to active and placebo arms for clinical trials as men are. I want to thank all the participants that contributed samples to this analysis. My mentor is Dr. Rachel Saunders-Pullman, who's shaped me into a movement disorders clinician. Dr. Bennett, and Dr. Alaku, who have run all the lipid activation pathways and abundances and interpretation that I've presented today. Dr. Yusuf Hanan and Lino Bade at SUNY Stony Brook, Dr. Crank and Dr. Burbula, and Dr. Fisher and Dr. Babcock at the NIH NINS, as well as the PDBP investigators, the Michael J. Fox Foundation, the Harvard Biomarker Study, and particularly express gratitude to the Silverstein Foundation. Yeah, that's a very good question and point of discussion. Yeah.
I could just say something to that, is that the issue is the age and onset of Parkinson's is generally also what would be equivalent to postmenopause in men. But certainly the reproductive factors and hormonal factors that are associated with the decreased risk of Parkinson's in women. Thank you. In women compared to men are of great interest. Unfortunately, despite many years of work in this regard, we don't have great answers yet. So I think it is something that we have to still keep in the back of our heads as far as how much is neurodevelopmental and occurring early in life, and then how much is hormonal, and especially the fact that some of these risk factors like caffeine
may exert their protective effects depending on hormonal levels in pre and postmenopause. Sorry, Casey, I took away your.
Thank you. Any other questions? Okay, thank you very much. So with this, we will conclude our first day. I hope you enjoyed it, and see you all tomorrow.